Okay, as I mentioned just a few minutes ago, when I started the first part of solving the exponential equations, I said there was two methods that we're going to look at. So that's the steps that I have written down here is for this other method. Again, just reminding you, this method that I'm fixing to show you would be one that would work for all exponentials. So you could go back to those previous examples and work all of those this way. But like I said, make sure you can work it both ways. Alright, so step one, you need to get your exponential on one side by itself. Step two, you're going to take the natural log of both sides. Now, step three, I said apply one of the following properties. So I do have examples, of course, using each property. This is one that we just learned in the previous section. When your argument has an exponent, then you're allowed to bring the exponent to the front. So that means you would now have that exponent times that natural log. So we'll use this on some problems. This one is one we learned, I believe it's two sections back. But this one's a little bit different because you've got a base of e right here. And of course, because this is ln, remember this is an understood e, so we have the property that states when these two things are the same, then this will just be equivalent to whatever the exponent is. So you'll either take it, from here and rewrite it this way, or take it from here and just write it this way. And once you do that step, then step 4, I've just said solve for x because it'll be an equation that you'll recognize what to do with at that point. Alright, so the first one. Alright, so step 1 was to get the exponential by itself. The exponential is going to be wherever you've got your variable in your exponent. So first thing I would need to do here is add 3 to each side. Okay, so now take natural log of both sides. So just put ln in front of what you have on each side. Okay. Now when it comes to picking the properties, the property that we're going to use on this one will be this first one where we just take our exponent and bring it to the front. The only time you'll use this one if it has an e in it. And obviously my base here is not an e, it's a 5. So you take your exponent, bring it to the front. Now since that exponent is made up of two terms, you do need to put it in parentheses. So x plus 1 times the natural log of 5 is equal to natural log of 11. Alright, so now we just need to work on, like I said, getting x by itself. Now natural log of 5 is just a number, and since it's being multiplied times the parentheses, then we're going to divide both sides by natural log of 5. So your 5's or natural log of 5's will cancel out. So we have x plus 1 equals natural log of 11 divided by natural log of 5. So last step then, I'll bring it back up here, would be to subtract the 1. Okay, now that's going to be your exact answer, but they're going to have you to round these off, and I can't remember how they instruct you in your homework to round. You'll just need to follow instructions. We'll just do it, say, to 2 decimal places. Okay, so entering this one in, I'll just show you my calculator real quick. I've not put in any extra sets of parentheses because your calculator will do the division before it does the subtraction, which is what it's supposed to do here. So rounding this to 2 decimal places, of course the 9 would round your 8 up, so this is going to be approximately 49 hundredths for your answer. Okay, next. Okay, so again, first step would be to get your exponential on one side by itself, which means I need to subtract my 1. Okay, now just reflecting back to what we did earlier about making our bases the same. See, I told you that process doesn't work all of the time, and it wouldn't work here because there's no way to rewrite 9 as 2 to some power. So you don't have that option here to get your like bases. Alright, so now that we have the exponential by itself, let's take natural log of both sides. Okay, I'm going to use the same property that I did just a few minutes ago. I need to take my exponent and bring it to the front. So I'll have 3x times natural log of 2 is equal to natural log of 9. Now remember, natural log of 2 is a number. It's being multiplied times the x. Of course, 3 is a number. It's being multiplied times the x. So to get rid of both of those, you have to divide. So you could actually just take care of that in the same step, since both of them require division. So your 3's will cancel. Your natural log of 2's will cancel. Okay, so this is your exact answer. And that's what we'll put in the calculator. Now, putting this one in the calculator, you will have to put a set of parentheses around your denominator to force that multiplication to occur first. So when you enter this in, you should get I would have approximately 1.06. Like I said, you do have to make sure you use parentheses there. Okay. Next one that we're going to look at. Alright, so my exponential that I have this time is the e to the 2x. So I need to work on getting this by itself. So first step to make that happen would be to subtract your 1. Okay, but I've got another step to go because I need to get rid of the 6, which would require that you divide both sides by 6. Okay, so now I do have my exponential by itself. Now take natural log of both sides. Okay, now on this one, going back to those properties, let me pull this back just a second. This time we're going to use the second property because I do have an e here, which means this statement is just equivalent to the exponent. So see, since I've got an e here, understood e here, this left-hand side is just equivalent to just 2x. So you can just take it and just pull it down. So actually, these problems that have the e actually is a little bit easier because of the property that you get to use. Okay, so last step would be to divide by 2. Now you can't cancel your 2's. Whatever number that you have right here after your natural log, you can't ever do anything to it. Don't add to it. Don't subtract from it. Don't reduce. It's locked in as being a 2. So natural log of 2 divided by 2. So to 2 decimal places, that will be approximately 0.35. So 35 hundredths will be your approximation there.